All about vermicomposting at WSU Puyallup. In this two-part video, we learn what vermicompost is and why we make it at Washington State University Puyallup Research and Extension Center from Dr. Doug Collins, a soil science and organic farming expert. In part 2, we learn the process of how to feed the worms in our continuous flow vermicomposting reactor. Part 1. Vermicompost. The what and why. What is vermicompost?
Vermicompost is the castings or the poop from worms that are used to compost food or to make waste that is potentially a problem into something really valuable. So vermicomposting is a form of composting that utilizes worms.
Why do we make vermicompost?
We make vermicompost, I think in this instance, the compost is really valuable. It's one of the best kinds of compost that you can get. But also, vermicomposting is a really good way to deal with small amounts of what we call putrescible waste. So things that are going to get pretty gross after like 2 weeks or 3 weeks. Whatever people have left over from their lunch, coffee, citrus, snacks that people are eating. We do have some people that live on campus that contribute to it. So these small amount, basically relatively small amounts of waste, and a worm bin is a great way to deal with that continuous input of waste.
How does vermicompost improve soil health?
Yeah, compost in general is really great for soil. It's a great source of carbon and other nutrients to the soil. But carbon, importantly, is the same or very closely related to organic matter. So when we say we're raising the organic matter levels of soil, a lot of that comes from the carbon. Organic matter is about 57% carbon. And so carbon is a source of food for microorganisms in the soil, so it directly benefits the microorganisms. And organic matter, carbon in the soil, provides surface area for nutrients to adhere to. It also improves soil water holding capacity. And again, it's that food source for organisms and also kind of a habitat for organisms. There's also other nutrients like phosphorus, calcium, potassium, magnesium, a lot of micronutrients. Those are all in compost, and those come along when we add that to the soil. So it is a good source of nutrients. It's important to sort of distinguish, I think, compost from fertilizer. In general, in most situations, you're not really looking to provide all of the nutrients from compost, but certainly micronutrients can probably be satisfied from adding compost. But there's not necessarily enough nitrogen for a crop if you're just applying compost. It takes a lot of compost to supply that. But it provides great benefit to the soil, and it can kind of help build soil.
What kind of worms do we use for vermicomposting?
The worms we used are informally called red wigglers, and they are Assinia foetida is the scientific name. In nature, they're what we would call a litter dweller, or an epigeic worm, meaning a worm that lives on top of the soil. So we have our anisic worms, which are the deep burrowing worm. When you think of an earthworm, that's probably what might come to mind. That's like a bigger, fatter worm that creates large tunnels and burrows. So those are anisic. And then there's endogeic worms who live in the soil and move more horizontally in the soil. They live kind of up towards the surface. They're smaller. They're about the same size as a litter-dwelling worm or a manure worm or red wiggler. And then that final category, yeah, those are worms that live above the soil, and you tend to find them in really high organic environments. So in a manure pile, in a pile of leaves. And those are the kind of worms that we're using in vermicomposting. So they like that habitat of high organic matter, kind of a nice bedding environment. So if you were to apply vermicompost to the soil, they're probably not going to colonize the soil. They're not going to survive. You can try to remove them all before applying, or they just kind of go along for the ride and they'll become organic matter. But that bedding thing is really important. In vermicomposting, having a good environment for the worms is the most important thing. You need to have sufficient moisture, aeration, so you need bedding that will sort of maintain its porosity. Some good examples of bedding are shredded cardboard like we use. Leaves are really good. Compost can be pretty good. Newspaper's okay if you ball the newspaper up into a tight ball so it has some structure and don't use too much of it. Yeah, those are kind of the best bedding sources that I'm aware of.
How do we run a successful vermicompost program at WSU Puyallup?
Our vermicomposting program at WSU is all volunteers. We look for people that are interested in learning more about compost, and we try to make it really simple for volunteers. So we try to have about 5 or 6 people, and then once a week that person is responsible for going around and gathering the food waste that is collected mostly in the lunchroom. We have also been getting food waste from graduate students and visiting scientists that live on campus here. And then we also have a facility for conferences. And so we also collect food waste when there's a conference or a meeting here. And so the person goes around and collects that waste and then feeds it to the worms. So we try to keep it, that would be like 1 hour every 5 weeks or so would be kind of what we're looking for in our committee of volunteers that help run the program.
Part 2, the process. How do we feed the worms? First, gather all the containers of worm food from their various locations and take them to the worm bin station. Keep track of which container came from which location for when we record data. Doug is going to give us a general overview of the worm bin and how it works.
So this is our worm bin. You could call it a continuous flow vermicomposting reactor because the continuous flow part is really key. In this system, we just put waste on the top of the worm bin, and then the compost, the vermicompost or the castings, come out the bottom here. So that is all essentially finished compost. Well, it's done, but it could be dried out a bit. In general, the worms tend to stay at the top. And that's one of the nice things about the continuous flow mechanism is that the worms, for the most part, stay in the worm bin. So we have this, this is actually a heat mat. I don't think it provides very much heat. The company suggests leaving it on year round. You can, even if you don't need heat, as you'll see, they really like it right under here. So we'll lift this up and you can see where a lot of worms are hanging out. So we have a really healthy system, no odor at all, no flies. These are all great things that you can sometimes find in compost bins. There's a grate under here that allows the compost to fall through, and it can be turned. This is basically going to scrape. There's a little mechanism that will scrape the compost. But if it's working well and you've got good bedding and good structure, then the compost just kind of naturally falls through. So you can see we actually are we're pretty well under capacity in terms of the amount of food we're feeding it. If we were closer to capacity, the level of the bedding and the food would be closer to the edge here.
Let's get back to the process. We will mix ground up food with bedding to feed the worms. After trying different materials, we found that the best bedding for our worm bin is shredded cardboard. Put a couple handfuls of the shredded cardboard into the white bucket and place it under the disposal outlet. Get the scale and clipboard out of the drawer and record the weight of the food scraps so we can keep track of how much waste is diverted. Don't forget to subtract the weight of the bucket, which is listed on the posted sheet. Next, dump the food scraps into the sink and plug in the disposal. Spray the bucket to get all the scraps out. You can separate the coffee and filters from the food as these do not need to be ground up. Use the wooden spatula to guide the food scraps down the disposal, but be careful not to hit the blades with it. Use enough water to get the food down, but not too much, as we do not want to oversaturate the worm bin. You can add the coffee and filters directly into the worm bin. Give the sink a quick rinse to get most of the bits down using minimal water. Replace the white bucket with the smaller gray bucket. Stir the ground up food and shredded cardboard. Spread it evenly on top of the worm bin. Spray out the bucket. Use the fork tool to spread everything around evenly. Next, use plenty of water to clean the sink and inside the disposal, with the disposal plugged in. After unplugging, check inside the disposal for anything that might be stuck. Then, take the gray bucket water and strain the remaining solids out to add to the worm bin. Because we have an experimental pervious pavement parking lot, you can just dump the strained water right outside. Lastly, take a couple scoops of dry compost and spread it over the wet worm food to prevent black flies because they do not like to dig for their food. It also helps with moisture control. Replace the heat mat. In the warmer months, you don't need to plug it in. Close the lid, turn off the water hose, and you're all done. All About Vermicomposting at WSU Puyallup was filmed, narrated, and edited by Stephanie Eckerd. Dr. Doug Collins is an extension faculty with the Center for Sustaining Agriculture and Natural Resources and an affiliate faculty with the Washington State University Department of Crop and Soil Sciences.